This is ImmunoAfrica, a podcast dedicated to spotlighting African immunology research.
Hello, I'm excited to have you join me on this edition of ImmunoAfrica's Graduate Student Series. This series offers emerging and aspiring immunologists the opportunity to connect with, learn from, and be inspired by some of the most talented immunology graduate students from Africa. This year, we peek into the fascinating work and busy lives of 4 immunologists in training, representing 3 African countries, Benin, Mozambique, and Nigeria. Vania, Segun, Onyeka, and Deo-Gracias joined me to talk about the challenges they are addressing in the field of immunology, which include training immune cells to fight cancers better, protecting fetuses from maternal parasitic infections, characterizing immune responses locally, and designing a multi-target vaccine. Away from their diverse interests and unique journeys, these talented scientists are driven by a singular purpose, an unwavering commitment to helping Africa realize its full potential in scientific research and development. Join me welcome our third guest, Seyigbena Deo-Gracias Berry.
My name is Seyigbena Deo-Gracias Berry, and I have been now living currently in Germany since 4 years now, doing my PhD in immunology specifically, and I'm mostly working in fetal-maternal area. So I started like my journey in Benin, and after my high school, then the university, I was really interested by everything beyond what we can see. And that starts since my childhood. I was really interested by what is inside the human, or any living thing. I was mostly attracted by the not knowing what is beyond what we can see, basically. And then I choose to continue doing after my high school, I choose to go for medicine. That was my first perspective. And then I found like my interest in the cell biology, because at the beginning we have to have some common courses, and I found out that I was more interested not only in the application of the medicine, but mostly, the how and the why. I decided to start applying for internship in the laboratory, in research laboratory back then in Benin, and to also, try to see what is in that side. And at that moment, I got the chance to work in the EITA, we call it a Tropical Institute of Agronomy and Tropical Agronomical Institute in Benin. So they have also some department in Nigeria and also some country in Africa. So I got the chance to work in a molecular biology research lab. And we were working that time in Boreli, USA. I don't know if you know about it. And I was really, really interested. I found myself, loving the way the other organism can influence the immune system or the microenvironment of the human system. So that was when I decided that I don't want to pursue anymore by medical study, but more going in research. And later on, I found myself loving more through the courses we were having, loving more immunology. So I decided to go for cell biology and immunology. After my bachelor, we were supposed to have 1 year break 6-month break, where you have to be in the clinical context. So going to the hospital, working in the laboratory, and kind of collaborating, basically. So this was something mandatory before you will be able to, continue or not. So then I got the chance of through the collaboration we were already having with this research lab, I got the chance to be in the hospital where the name is in French. I will try to say it in English because to know it properly, they call it in French, Centre de dépistage et de traitement du sel de Burley. So this means the center where they do the detection and the treatment of patients who had Burley ulcer. I was really lucky. I think I always said this phases where I was in the hospital was the path who lead me to where I am now, because being in contact of the patients coming in the lab and discussing with them and also learning, reading more about the disease helped me to see where I want to be. So for me, it was the moment I decided that I don't want to be only a researcher being in the lab, but I want to also go to the people, interact with the people. But most importantly, I want to be more into the disease, not only being in the lab doing the research about the disease, but knowing the functionality or how the disease arrived to overcome our immune system. So that was the moment I decided to go in master after my training. So from 6 months, I decided for 3 months first, I decided to go for 6 months in that research center. And then I decided to go for 1 year. And then after that, I registered for my master, but then it was then in cell immunology. So cell biology and immunology, not anymore in molecular biology. So, and I got lucky to find myself in another team where they were working on malaria. So basically, they were working on malaria during pregnancy, but also trying to find a way to prevent, the malaria before the pregnancy, in order to, basically help the newborn immune system, because having you have the normal malaria, but you have also the malaria during pregnancy, which affects also the baby immune system. So basically shape the baby immune system. And most of the time when a woman get pregnant and then got the placental malaria, as we call it, so the baby had this we train immunity somehow. And then during the first year, the baby is more susceptible to have the cerebral malaria, because his immune system get used to the antigen of the malaria. So basically, it will not be detected as foreigner. So the immune system will not alert the rest of the process. And so exactly. So basically, before it get detected, really is already in the cerebral stages. So it's more fatal for the baby and for the first year for the 5th year. So I was really lucky to get into that team, and I found myself loving more what I was doing, and be really feeling at my place, feeling myself where I want to be. So that was how I really started being in immunology. And later on, I found myself after my master on a project regarding another parasite, not the malaria, but schistosoma, so basically the ailment, but specifically the schistosoma hematobium, but also in the pregnant woman. So that was basically my master shape, kind of my a thesis, my PhD thesis. So then I start going more in the fetal-maternal area. So basically, yeah, that is how, like, slowly how I end up, in fetal-maternal area, but also not only malaria, but then I will call it tropical diseases.
Thank you. I think that's quite a long and very fascinating journey. Okay. So your interest developed slowly, and when you had the opportunity to work with in the field of molecular biology, work in laboratory settings, still, it just wasn't clicking that this is what you wanted to do. You didn't feel
No.
fulfilled, right? Until you had to work on immunology related project, and then your master's program provided that ample opportunity for you to do immunology work in the context of malaria, and but also now in your PhD, you're also working in the context of immunology. I would say building up on what you did during your master's, working with mothers and infants, or like you described it, maternal fetal, that relationship. So yeah, quite interesting, and thank you for sharing. You've kind of opened the door to your PhD work, and which you are currently exploring at in Germany at the Technical University of Munich. And so I want you to tell us more about that project. What are the questions that inspired the project? What kind of problems were you looking at tackling when you started working on the project, and even now that you've been on the project for close to 4 years?
So this journey start like kind of like I didn't expect it. So there were a project they were already conducting. I think they had a pilot study in Gabon, precisely in Lambaréné, where like schist element infection are really endemic, and also the in co-infection context. So not only for ailment, but malaria. Gabon is highly endemic for ailment, but also co-infection with malaria and other parasites. So the idea was to assess the maternal ailment infection, on the vitamin D regulation, but also on the immune system of the infant. So the pilot, as I was saying, they had a pilot project, and the pilot project was comparing Gabonese and also a German mother-infant pair. And that project was mostly about like the environmental factor which can modulate the maternal immune system during pregnancy, or which can influence, if I can say it like that, and then how these factors during pregnancy affect the baby. So that was kind of the project, the pilot project, and they find out that like there were differences between the regulation of the vitamin D receptor kind of in the Gabonese mother compared to the German mother. So the Gabonese mother had less vitamin D receptor compared to the German mother, even if though the Gabonese mother had enough vitamin D, soluble vitamin D in the body. So then I was then, going to the direction to see if only in the context of a Gabonese mother, taking the infected mother with schistosoma hematobium and the non-infected for the schistosoma hematobium, and also some GEO element, if we will have differences on the soluble level, in the maternal side also, or in the fetal side, but also see if, the infection will have any influence. So that was kind of how the idea started. And I was talking about schistosoma hematobium. I don't like to break it a bit down. So basically, schistosomiasis as a global disease concept is linked to the poverty, and is present in Africa, but also mostly in Africa, but also in Asia and South America. So it worldwidely is like in 78 countries, and we have like around 240 million people infected worldwide. So, and currently WHO published that like more than like 700 million people are estimated living in the endemic area, not only Africa but worldwide, you know.
Mm-hmm.
And I was in Gabon, in Lambaréné precisely, where we had the study going on. The species which was like endemic or which is endemic in that area is the schistosoma hematobium. So to break it down, we have a lot of species of schistosomiasis. So you have the schistosoma masoni, the japonicum. Like that; those are the most common, and you have the hematobium. So in Gabon, the one which is endemic over there is hematobium. And you have to know that like worldwide also like around 40 million women are in age of reproduction are infected. So in those endemic area, especially for the schistosoma hematobium, we have the issue that those women can get the urogenital schistosomiasis from the schistosoma hematobium. And this can lead to a lot of disease, and like the most difficult one, and which is not well known, is like the cancer. So these women can get the cancer from the uterus. So it's like really difficult. So we decided to go for, understanding first, because there is already a lot of study going on in that area for the schistosoma hematobium, but also other ailment species. But as I was saying, during that pilot project, they find that they didn't went for only schistosoma infection. They went for the ailment infection. And in ailment, you have also the geo ailment, And from there, we decided to go for the one affecting more the pregnant women. So, which is the schistosoma hematobium one. And that was when I come on board, and we started thinking about how this can affect the maternal immune system, but not only her immune system, but also like the soluble factor, which are necessary for the progression of the pregnancy, but also shape kind of the baby, formation and the immune system. And from the perspective of what they saw in the pilot study, I have to say that like going into the study myself and then starting reading about it, and in order to write my protocol, I find myself learning a lot about vitamin D. And at the beginning, I didn't know, I know we need some vitamin and so. But for me, what I know, from being just not scientist, but from the common knowledge was like that the vitamin C was really the one we need the most, from common knowledge. But then I find out that, wow, the vitamin D also is really important in the body. Because not only for, like from the perspective, not only the pregnant women, but like generally, the vitamin D is the one activating the calcium, absorption, the activation and the regulation of the calcium. The vitamin D is the one leading that. And then we have also the absorption of like the phosphate, like all these other ion activation are basically linked to the vitamin D, regulation. And most importantly, during the pregnancy, we know that, calcium is important for the shape, the bone mineralization, the shape, the shaping of the baby skeleton. And we have also other absorption, other nutrients, which are important for the formation of the baby and its survival, right? And the vitamin D is really important for all these events happening. Because if you have vitamin D deficiency, this also can affect the calcium activation, the calcium absorption. But most importantly, we have also the vitamin D being produced like locally in the placenta, also for the baby development. And it was really surprising for me because I didn't know that. And I started going, more deeply into that and looking in that direction. So that was how, my project, my thesis project was, like I would say, find, the shaping, So basically it was from a pilot project, but also from starting reading and learning and then finding my way of combining, how the maternal infection could affect for schistosoma hematobium, could affect, specifically the other soluble factor that the mother have, but also can also affect the baby immune system and also the baby soluble factor, kind of a the trained immunity kind of, So it was how I started. And so far, I'm really, I had one of the question that I found surprising, if I can already address it. One of the things I found really surprising is that in context of my study, I find out that even though the mother had infected for schistosomatobium, or like in my context for schistosoma hematobium, for example, I find out that if the mother had sufficient vitamin D level, like basically coming from the main source of vitamin D, which is the sun, or also from like proper food balance or food source of vitamin D, she doesn't have any modification from the maternal infection, but also this doesn't affect also the baby as like level of, of vitamin D or level of calcium, even though they are in context of chronicity. Also, we find out that like when the mother had sufficient vitamin D, they have less risk of having baby with low birth weight. So it's really really something that from the policy wise, I don't know if I can say like from the policy view, is really a good public health information, because this can help then to balance, the effects of the infection in the endemic area. We can, through that also, help the pregnant women to at least have the proper amount of vitamin, and this also can help the immune system of balancing and fighting the pathogen somehow. So yeah, that is a bit what I can say so far about my project.
Thank you for sharing. Uh, I'm just trying to just piece together all the things you've said. So basically, your research was an offshoot of a pilot study that had been conducted involving, mothers and their fetuses, and then the environmental factors that could influence vitamin D levels. And then they found out that in this part of the world, in Benin, or where
In
they studied in
Gabon,
Gabon, yeah, sorry, in Gabon,
yeah, in Gabon and
vitamin D
Liberia.
levels were quite high, but they were less receptors. But then that was
Yeah,
different from Jenny, where the vitamin D levels were lower, but then there were more receptors. And then that influenced your
yes,
study, where you were now
yeah.
looking at vitamin D in the context of helminth infection, schistosoma hematobium, and
Mhm.
helminth infection, and in the context of pregnancy. So, and then trying to understand how helminth infection can modulate or influence vitamin D transfer, or the vitamin D transfer from mothers to infant to fetuses during pregnancy. And then you found out that provided there's sufficient vitamin D, uh, the infection, the infant tends to do well. So they get sufficient vitamin D from their mothers. And then did you also mention that they are also not affected by the helminth infection?
Yes,
Yeah,
yeah.
okay, good. So
We
they also
didn't
don't,
find
yeah, they also don't
we
get the
didn't find also the modulation, like even though the mother were infected, we didn't have any influence on the mother baby side.
yeah. So
So
the babies are not
the soluble
infected.
fat, yeah.
The babies are not
So
infected.
we didn't test the baby. So
Okay,
basically the thing was like, as I said, we categorize according to the maternal infection, right?
okay.
So the pair we had, if the mother is infected, we consider the pair as from the infected
Infected.
group.
Okay.
But the point is like, even if though they were in the they were in the category of like infected because coming from infected mother,
Mm-hmm.
the calcium, the calcium or the vitamin D
Vitamin
level
D.
were like even if higher in
Yeah.
the cord blood compared to the maternal blood. So
Okay.
basically, you have the sufficiency and you have the transfer being maintained.
Mm-hmm.
So the maternal infection didn't affect,
Affect
the transfer of those soluble factor necessary for the baby
development of the,
development.
yeah, yeah.
And yes, that's what we found. And also we find out that even if though the mother is infected, having sufficient vitamin D prevents to have basically being a beneficial factor for having a baby of
Low
low
birth
birth
weight.
weight.
Yeah. Yeah, I got
So
that. Yeah.
having insufficiency vitamin D, even though the mother is infected, is a protector factor for her. So
Yeah.
basically, she has less risk of having baby from a low birth
I know you're working with women from Gabon. So,
weight.
um, was it assumed that all these women have high levels of vitamin D because they are in this part of the world, or were there any amongst them that didn't have sufficient levels of vitamin D?
In our group, we had some people who doesn't have a sufficient level, but it was really low. They were really low. Like, if I can recall, I think it was like only, I think it was really low, less people having like less vitamin D. So only 11. So basically, only for the vitamin D insufficiency, we found only 28% had vitamin D insufficiency.
Okay. Did that affect?
So
Yeah. I'm just wondering if that affected um, if what was the impact of helminth infection for those women that had low vitamin D levels?
we didn't find also any from the mother who had like low vitamin D.
Yeah.
as the vitamin D threshold was low, but not that low. Let's
Okay.
say so it was less than 30 nanogram per ml, which is like the recommended one. But
Yeah.
like it was not kind of like it was also between not lower than 20.
Oh,
So basically, they had, even though it was lower, they had enough, So we didn't find any relationship also through the infection. But I think we can say that because they have also well-balanced food source, I will say, this
okay.
also can be a protector factor
Okay.
somehow
Okay.
for the mother also. But
Okay.
for sure, the transfer was not affected, or the intrinsic production of the vitamin D in the placenta was not also affected in our
Okay.
study.
Yeah, thank you. Thank you so much. Great. So, but I'm just wondering, it appears you didn't really get to work with immune cells for the first part of the study. And
No,
like the immunology context of this study is the role that vitamin D can play in immune function and anti-inflammation and how just to modulate the immune system during an
yeah,
infection.
and
Actually, yeah, please go
that
ahead.
is what I'm doing in the second part
Yeah,
right
yeah,
now.
yeah, yes, I get
So
that.
the first part was quantifying or uh, through the serum specifically,
Mm-hmm.
basically. And right now I'm using the cells that I isolated from the blood I took during the field work, and that is what I'm doing right now.
Interesting. So I think you have to keep up. You have to. I think you have to keep us posted on the outcome of the
Yeah,
second phase, so
for sure.
we can update everyone that okay, this is what Deo-Gracias found out from the second phase
I
of the
will
study.
send I will send around also once it will be
Yeah,
published.
great. Yeah, well done, well done. Talking about vitamin D and how that you don't get enough sunshine in Germany, I was just thinking that perhaps you miss African sun. I know it can.
A lot.
Yeah.
Oh God.
So yeah. So maybe you can just tell us maybe if there are other things you miss about the continent as someone who is in a foreign country, apart from the sun and the fact that you now have to take vitamin D supplements. What else do you miss about the continent?
The social life we have
Oh.
back home
Mm-hmm.
is something really heavy when you live abroad. Um, Especially when you are in science, because you need also life balance, and that is something I learned from the experience of working in not only as a scientist, but I learned that you need a balance in everything you do.
Yep.
You need a proper balance. And being here make me realize that, wow, back home you don't make that effort to have the balance because the social life bring you to have the balance, or somehow force you to have that balance.
Yeah.
Even if though I will be working like all the week in the lab, for example, during the weekend, like Saturday, even if I have experiment, in the morning, I will have something planned already with a friend, or like even if I don't have something planned with the friend, I have something with the family planned. And even if you don't want somehow sometime to go, you
Yeah.
have to,
You have to
right?
go. Yeah.
And this force you somehow to have a balance.
Mm.
Here, most of the time you are alone, right?
Mm-hmm.
And most of the time you forget even if your own life. And the only thing you have in mind is like, I'm here because of this work.
Yeah.
So I have to do everything in my power to make this happen.
Yeah.
And I will find myself being 7 days in the lab, 24 hours. The only break I give myself is going to church sometime. And I realize that this is not healthy
Mm.
because at one point I start having some breakdown, because this is part of the experiment. When you have really heavy day in the lab and then the experiment didn't work the way you
You
wanted,
expected, yeah.
this hit you really, really badly, and as you don't have anything anymore, you want to do, because you are not even, you don't think anymore about doing anything else except to work.
Yeah.
You realize that this is not a healthy life I'm having, So that is also something I miss a lot, and something that we tend to forget, having social life when we are doing research. It's difficult, for living that, it's difficult to not being, saying like, I need to, but we need to find the balance as well, because this also help with the how progression of
Your work.
our work,
Yeah.
So it's really important. If I can, from what I learned, if I can give any
Yeah,
advice to
you can just
anyone
share, yeah, some time
doing
management tips and what
PhD,
works for you.
yeah, as like for me, I just choose to do what I can do, maximize what I'm doing in the working hour.
Okay.
If when you have the experiment, that part you can't really control, right? Because experiment, you have stimulation stage, you have to be on time, right, for this and that. But then at the same time, you have incubation time during sometime.
Mm.
Sometimes you have 1 hour, sometimes it's 2 hours, sometimes it's 30 minutes. So it's you have to find, sometime I just decide to go for ice cream walk when it's summertime, or then I just decide to go for having coffee with the colleague during the break, at least to have a social life,
Mm.
with the colleague when I'm at work, to not be only into science.
Into work, yeah.
This break, sometimes this break give you more, even if than, and help you to have more clarity,
Mm.
you know than when you are like during the break or during the incubation time, reading again something and being to science, because your brain need
You need,
also a break,
you need
you
space, yeah.
know and I had yeah. And since some time, I had a friend of mine. She knows that I love to dance. So sometime also when I have a break like that, and then I don't want to talk, and I'm in the bad mood because something happened that I didn't like, I just go in the changing room. I put my headset, I put music, and I dance alone in the in the changing room. And after dancing for a while, I'm feeling again happy.
Mm.
And okay, so it's for me. I just try to, knowing myself, trying to find stuff that help me. And also I start going out with some of my friends, during, even if it's really late in the night. Sometimes, for example, sometimes I finish at 10 or 11 9, and my colleague will be, oh, we are going to the restaurant, do you want to come? Before, I always say no, because I'm like, I need to rest and then tomorrow. But now, I'm not saying yes all the time, but
Yeah.
now at least, I find that it's also okay, to just go to the restaurant with some of my colleague or my friend, and even if it's just for 30 minutes, this will also help to have life outside, because I'm all the time in the lab also is not good. So
Yeah.
that was my way. So I will say the person has to find his way also of having his balance.
Yeah.
Yeah.
Great. So, talking about spending long hours in the lab. So I believe you've learned so many skills now, and there are so many immunological techniques or cell biology or molecular techniques that you can run. So maybe just highlight for us some of the skills that you've learned in the course of your work that you've maybe become proficient in as a result of your research.
Before I started my work, I had the chance, as I said, to work with the molecular biology. So it was mostly going for a conventional PCR and qPCR, quantitative PCR. Then, I started with the immunological assay, so ELISA, and I was lucky enough to work in the lab where they had they have the ELISpot technique, which was already established. So I used that for my master. And I started, being introduced to the flow cytometry, which is the major immunological technique in terms of immune cells.
Mm-hmm.
And I get some introduction, but I was not really, I couldn't call myself expert in flow cytometry. But for the other one, I can say, yeah, I have, how you call it, expertise in that. And I found myself being really lucky enough to be in the lab where I am now, where we have like the flow cytometry department well established. So I really get to get used to that, learn deeply. So actually, I can be proud to call myself flow cytometry expert, and I'm really happy about that because it's really important in immunology, actually for the cells phenotyping and characterization, cell sorting. So it's really good. But also, I was lucky enough also to learn more about one another technique, which is a luminous technique, and it's also immunological technique, bioplex technique, kind of ELISA, but like applied to so it's really, yeah, those are like, if I can summarize.
Yeah.
So those are the technique I have right now. And during my thesis, I'm really grateful that I was able to learn deeply and understand more the cytometry.
Yeah, thank you. So I'm also curious to ask about in the course of working with some of these techniques, is there any mistake or failure you remembered that you can share?
I'm not sure if I can call it a mistake.
Okay.
So the first thing I encounter for my thesis was that during my master, I didn't work with the cord blood directly, right? So I know the processes of the isolation, the cell culture and everything, but the cord blood was not part. So when I started my thesis and we took the blood, I used the same kind of protocol, applying for the peripheral blood to the cord blood.
Oh.
And I realized, like, it was supposed to be the same thing because it's the same processes of isolation.
Okay.
But then after being at the end, because after when you isolate the cells and go through all the processes, you have a purified cells, right? Being the proper layer, and then the coloration is you expect some kind of coloration as well. And I had that in the maternal blood. And for the cord blood, it was so red, kind of like I didn't do any purification. I went through all the step, and then I was like, why is that so red? Why? And then from reading and also trying to contact, then I started contacting, other people working with cord blood. And I was lucky enough to had a conversation with one researcher from the team I was working in Benin before, and she worked mainly in a fetal-maternal area and with cord blood. And through my my previous boss, who was also there, we had a meeting, and she explained to me that the dilution factor that you will use for the maternal blood, you need to double it for the cord blood, because the red in the cord blood you have more reticulocytes, which are the pre-erythrocytes. So basically, like the red blood cells.
Yeah.
So you had the immature blood cell, red blood cells, which are called reticulocytes, and they tend to get sticking themselves to the layer of like the mononuclear cells. So in order to get rid of them, you have to dilute more the blood. Exactly. So I was like, the first time I had it, I was really afraid. I thought, what have I done?
Yeah.
And then, I learned from that. And then I realized that, so I experienced that for the next cord blood during my training. And then I had the dilution, and I was like, wow, I was really happy about the result at the end.
Great.
That was one thing I learned from that. And so I had that expertise, but then, applying that to the context of cord blood, I learned another part, or I can say I learned something new specific to the cord blood, right? And then from the technique, I will say for me it was, as I said, I get some introduction to the flow cytometry, but then I was not really familiar with the machine, being alone on the machine. So the first time I had the introduction, another introduction here, and then I did, I was supposed to do like kind of basic and running, and also how to start the machine and everything.
Yeah.
And I was a bit lost. I was a bit lost, and it was like really, I was terrified, because for me, I was like, the machine started having noise, and then I was really, really, because I was alone in the lab that day, and I was so terrified. I started crying alone, because I thought I break the machine. I did something wrong, and I didn't know that it was supposed to be like that. So that was the second thing.
Yeah.
And the third thing was then when I get the result of, because you have to run the experiment on the machine, the flow cytometer, but then you have to analyze them in a software called FlowJo. So I never did that. So the first time I did it, I was like going online, just watching some, how you call it?
Videos.
Some videos, exactly, thank you. And then to see how I can do it. And then I watched it, I thought I understood, then I tried to do it myself. I did it, but I can't say I know what I was doing. And then I sent the file to my supervisor, kind of, at that moment. And she was so rude. She just wrote me, "What is this nonsense you send me?" So basically, I did the analysis, but I export, like the way to export them, I export everything without following the gating strategy. So I didn't know, like, I watched the video, right? And then I did the analysis according to the way it should be. But then the way to export them and following which strategy, I did my gating, I didn't export them that way. So I export everything as like file, and then put them in the PowerPoint, and then I send it. And it was kind of a slap in my face, her message. And that was so hurtful. I was like, geez, what is this? And this was kind of like doubting myself somehow. But I was also lucky enough, to have a discussion with another postdoc who work in the lab, like in the same group. So I went to him and I was like, these are what I did. I sent it, but these are the feedback I got. But it was not constructive feedback, the feedback was just like kind of a slap in the face, not like, this is what you done wrong, please do it this way. And I was like going to that person because I know that he worked with it, and I show him and he was like, okay, this you did them well, but this you did them wrongly, so you have to write basically down, kind of protocol. You have to break down what you did, and while exporting them, you have to show the progression of what you did. Yeah.
Yeah, thank you. Thank you for sharing and sharing some of those. Some of them were appear to be like embarrassing moments for you, but of course you've learned
Yeah.
from them and you're better now.
Yeah, for sure, for
Yeah.
sure.
So, what are like some values that you cherish if you were to maybe describe yourself or your kind of person? What are the values that stand out for you?
For me, respect, um, not only other people, but the respect for yourself,
Self-respect.
self-respect, and work ethic.
Mm,
You need to have a strong work ethic, and that is what I, value the most. And my dignity. Um, for me, it's even if my dignity come before everything. Like for me, and through through the dignity, you learn how to respect yourself, how to have a really strong work ethic, but also enjoying what you are doing.
mm,
So as for myself, I always tell myself, uh, as long as you have your heart beating, everything is possible. So go for it. If you feel it in yourself, go for it. Never back down, even though it's difficult. Stand for yourself, vouch for yourself, but don't lose yourself in those in the way of pursuing those objectives. Don't lose yourself. Stay true to yourself. So it's the only way you can achieve something and be
yeah,
proud of what you achieve. So yeah,
yeah.
if I can describe myself, those are
Yeah,
my principle of value.
yeah. Thank you. So, self-respect and dignity, strong work ethic, and I think
Yeah,
I would describe it as a never give up spirit. So always,
yeah,
ensure that you are giving your best and that you are pursuing what you want. And in fact,
yeah,
also very important, while doing so, you shouldn't lose yourself, which relates
yes.
back to the whole idea of having a very strong self-dignity. It's a very strong sense of dignity and self-respect. So thank you. I think we've had a great chat so far, learning about your work on a disease that affects 240 million people in the world, and a large percentage of which are women who are in the reproductive age, who your research specifically targets, especially those who are of childbearing age, like you said, and looking at how we can limit the impact of the disease schistosomiasis on them and on their fetuses or infants, as it were. So thank you so much for your amazing contributions, and I think we've had a great
Thank
chat
you
so
for
far,
having
and
me.
for all the beautiful perspectives and insights you've also provided. So we'll be wrapping up the episode with two fun questions, and so I would ask them next. So I hope you're prepared.
I hope I'm prepared.
So I'm just wondering if there's like a favorite immune cell for you. What's your favorite immune cell, and why would you think that would be your favorite immune cell?
I would say my favorite cells are stem cells,
Mm-hmm.
even though I'm not currently working with them, immunological point of view, like the stem cells will be the one if I will be the cells, immune cells, I would like to be the stem cells.
Okay.
Because they are the one from which all the other cells originate. So kind of they are the basement, of the house, if I can caricature it like that. And they have two like major importance or like important properties. Like first, they can renew themselves, they can produce or make more cells like themselves, and they can also differentiate in other cells that we have, all these lymphocyte, monocyte, whatever, eosinophile, neutrophile, they can differentiate according to which direction of the immune system the T cell are need for. So for me, it's quite fascinating. So and you can find them in mostly all the tissue of the body. So yeah, that is the reason why I think I like them and I would like to be a stem cell.
I think it's a great choice actually, and I didn't know you think towards the direction of them stem cells because they're not like conventional, but yeah, they give rise to
No, yeah.
different cell types, and I think that's a great choice. So you'd have indirectly you can be anything you want to be and still retain
Yes,
your
exactly.
unique quality. Yeah. So thank you so much, Deo-Gracias, for a great chat and for the amazing work that you are doing in the field of immunology. I like the fact that your work has very direct impact on African women, and particularly those who live in regions that are where we have a high incidence of schistosomiasis and of course, we already have a very good, we are blessed with a good dose of sunshine. So I'm looking forward to the findings from the next phase of your work. And so we'll know how to, tailor some of these discoveries to better support these women and ensure that both them and their infants are safe. Thank you.
Thank you for listening to this episode on ImmunoAfrica. If you enjoyed it, please feel free to share it with your network. You will learn first about future episodes and get other immunology related updates by following ImmunoAfrica _other Immunology in Africa podcast on social media. See you on the next episode. Bye.